only these two process only we have in semiconductors. Either it will travel as a drift process, by drift process, or diffusion process. Okay, drift means you need a lower concentration to, suppose electron want to go from low concentration to high concentration, here to here, low to high, just here low to high. So you need some external field, that is here we will use electric field to send. Okay, for diffusion, high to low, high to low, this will, because it is no need to any force, because high concentration easily it will go to the low concentration. Suppose if you take electrons, so electron we are taking current density, current per unit area, current density means current per unit area, we are writing for electron. Electron can diffuse drift. Okay, total current due to total current due to electrons, or you can write equation current electron current by drift and electron current by diffusion. Okay, so if you write these two equations, okay, here E n mu n, this is the mobility, n is the charge carrier concentration, and E, okay, E is the electric field, or you can write Ohm's law in conductors, are you can write J is equal sigma. This is another form of Ohm's law. Okay, this is simply, here you can write this part, you can write E, sigma. Sigma means conductivity. Okay, drift diffusion means, here also charge, electron charge. This is the diffusion coefficient, how the efficiently charge carriers are diffusing from one region to other regions. That explain. Okay, this is the charge gradient dn by dx. Okay, it will explain, or dn by dx means rate of the concentration per distance, or some distance. So, sorry, one second. Okay, how the charge carriers will, just for the interruption. Sorry for the interruption. Okay, feel good. So here dn by dx means rate of the gradient charge concentration for a distance. How much this so how much a concentration is varying. Suppose if you are sending from this charge carrier concentration or charges from 1.1 to 0.2 position. Okay, 0.2 position. Here we are sending some 10 electrons here. How many electrons are reached here? How many electrons are reached? It will explain. dn by dx is how much charge carriers are diffusing for a length, for a some distance, or you can take distance or length. So here we will take a length, because only semiconductors are like centimeter, meter range, centimeters range only. So that's why we will always take length. Okay. So that is the charge carrier gradient. Okay. This is the total current due to electron. This is first term is drift process, and second process is the diffusion process. Okay, this is derivation part, no need. Okay, this is only just a small question you will get. Okay, similarly holes also you can write. Similarly holes also, here E, that is a charge of electron holes, and P is the charge carrier concentration or hole concentration, or you can write density of holes also, you can write same thing. Okay, mobility of holes. This mobility means how the electrons and holes will move within the semiconductor, that will explain. Okay, how easily it will move one place to other place, it will explain. Mobility means. Okay, here also you can, here you can write minus. Okay, here minus. So E dp and dn by dp by dx. Okay, same thing, just here you will have a minus, because so here if you take any semiconductor, here charge carriers are leaving for electrons. Okay, for this p type semiconductor, charge carriers are coming. That way we will coming and going, that way we will take here we will get some minus term. That's it. Other than remaining all are same only. Okay, that's it. This is the uh, carrier transport, you can say if they ask write the carrier transport about please write down one paragraph about carrier transport. If they ask, just you have to write drift process and diffusion process. After that, you write equations, that is more than sufficient. Okay, definition, and what is the definition, and you write these terms, and that's it. Okay, this is more than enough. Okay, and all effect, using all effect also we can estimate sigma is equal to what we have taken here, E n mu n. Okay, mu n means mobility. You can calculate mobility also, and you can calculate using Hall coefficient. We know Hall coefficient is 1 by ne. 1 by ne. From this equation we can write 1 by ne is equal to mu n by sigma. Sigma is the conductivity of this semiconductor. This we can know. You measure the IV characteristics and you can calculate conductivity, and from this Hall coefficient you can estimate what is the mobility of a semiconductor. This is the simply about carrier transport drift and diffusion process. Okay, that's it. Okay, is it clear to you? 35.
Yes, sir.
Yes, sir.
Okay, I forget your name. What is your name? 30.